CV sir, good morning. CV sir, good morning sir.
சார் மைக் அன்மியூட் பண்ணணும் சார்.
Okay, okay sir. So day
Yeah,
one
good morning.
post-op.
Good morning to all.
Good morning sir, good morning. Sir, we'll start by 10 sir.
Okay, sir. I'm waiting. No issues.
Okay, okay.
Waiting.
Rahul sir,
Yes, sir.
Moorthi sir, shall we start now, sir?
Yes, sir. Yes, sir.
Yes.
I'm ready.
Yes. Okay. CV sir.
Okay, sir, I'm ready.
Okay. Rahul sir.
Okay, sir. Good morning to one and all present here. This is Mr. Rahul Kumar J, Assistant Professor, Department of Electrical and Electronics. On behalf of Dr. NGP Institute of Technology, Coimbatore, Tamil Nadu, India, we are extremely happy to coordinate the AICT sponsored HTTP short time training program for 6 days, start from today, 28 September 2020 to October 4, 2020. Phase 3 on the topic Machine Learning and the Internet of Things IoT for Industrial Applications. In this wonderful and grateful occasion, we heartfully thank to AICT for sponsoring to conduct this HTTP virtually on this pandemic. Regarding phase 1 and phase 2 of our HTTP program, we are very much thankful to participants for wonderful coordination and healthy active participation. And some details regarding phase 1. Number of registration we received with short period of time is around 1100 responses for phase 1. Then we limited and shortlisted to 230 participants. Finally, 158 participants received certificate in phase 1 successfully. Participants for phase 1 from worldwide, which include postdoctorates, doctorates, associate professors, assistant professors, lecturers, and research scholars. In phase 2, total responses limited up to 500 we received and shortlisted around 200 participants. While shortlisting, finally 155 participants completed successfully and received certificate. Participants are from globally, and now we are in phase 3. We limited response around 240 registrations and shortlisted around 150 participants. We congratulate and thank you all for registering this phase 3 HTTP. Now, participants are from worldwide, especially from India, Saudi Arabia, Finland, West Africa. Thank you all for registering this HTTP. Then, some words about our institution. Dr. NGP Institute of Technology. Our beloved chairman, Dr. NGP, initiated the establishment in the name of Dr. NGP Institute of Technology. Is the premier engineering institution promoted and run by Kowe Medical Center Research and Educational Trust, Coimbatore. The institution approved by AICT New Delhi and affiliated to Anna University Chennai. It is also accredited by NAC, NBA, and recognized by UGC. At present, institution has 7 UG programs, 5 PG programs, 4 PhD programs. Under the umbrella, Department of Electrical and Electronics Engineering was established. It's used for excellence in the core field of electrical and electronics engineering. It provides an international ambience in a local setting with innovation and innovative and encouraging teaching methods, workshops, lecture series, industry institute interaction, seminars by eminent speaker, virtual industry tours, and research activities. Department offers an comprehensive array of courses that encompasses the undergraduation, post-graduation, and doctoral level, with an objective of imparting quality education and research whilst leading on the innovative curve. Also, our department organizing several guest lectures with eminent people from a leading organization and institution in and around the country. To, to enrich students and faculty with innovative thoughts in the different ways, our faculty and students are active in participating in receiving many awards, various challenging roles. With this short intro, I hand over the session to our department head, Dr. S. Jagannathan sir, Professor and Head of the Department Triply, Dr. NGP Institute of Technology. Sir, please take over the session. Sir, Jagan sir. Sir, Jagan sir. Okay. Now I call upon our senior professor, Dr. C. Vivekanandan sir, professor and head of the department, Science and Humanities, will illustrate.
Thank you, Mr. Rahul, for your introduction.
Yes, sir.
ST function, Dr.S.Moorthi, electrical and electronic colleagues of NG organizers and participants from all over the world. A pleasant good morning to one and all. I deem this as a great honor to be amidst you for this wonderful inaugural function. And this is the third session of this faculty development program. Already 2 sessions are completed. And I'm happy to note around 170 participants in phase 1, 150 each in phase 2 and 3 are getting benefited. All our faculty members, teachers from renowned institutions across the globe. And the theme of this phase 3 is a wonderful theme. It is AI and machine learning. The recent outbreak of COVID pandemic, though it has affected the basic livelihood of common man across the globe, it has taught us several new lessons. It has provided us platforms to enrich our knowledge, to expose ourselves to new things, which we are not exposed so far. Because if you take me an example, I am running 55 now. The past 55 years, barring the 10 years in my childhood, for the past 45 years, I have never come across such a worst scenario in my life, this COVID pandemic. That is one side. But on the other side, COVID pandemic has opened avenues which we haven't thought of all those things before 6 months or 8 months. We have never thought of online sessions, online classes. We never thought of such online FDP programs, faculty development programs, and other programs. We never thought of working from home, and we never thought of even conducting examinations online. Had it been told before some last year, would have laughed at it, right? So online exam, how is it possible? All those things, of course, it has taught us a new thing, and we have learned it, right? We have learned several new things from this COVID pandemic. So it is, we are adapting ourselves to the unexpected scenarios and unexpected environmental conditions. So this is the nature of the human, right? So we as human have the potential. God has given us that sixth sense to tune ourselves to get accommodated to the demands of our day-to-day life. So how come this can be incorporated into our mission? That is the work going on for the past 3 decades. Because to the best of my conscience, this is a ML, machine learning was introduced late 19th century, around 1990s or 95, which is an extension of artificial intelligence. Artificial intelligence is a very big area, and this machine learning is a subset of that. Subset of that. And machine learning is a process to empower the machines, which are all or what we call in Tamil we call it as organic vertical. These machines to enrich their knowledge, to fine tune their knowledge, to learn new things from their experience. Okay, as we learned from the similar to our COVID pandemic, machines are also tuned to learn something from their experience. Of course, there are already some tracker systems available. You can talk about Apple Siri or your OK Google, Alexa. All are the currently available machine learning systems which we come across. Because one of my friends from US, when I met him last week, or over phone, of course, our this WhatsApp, he said he cannot think of his life without this OK Google. Okay, so everything he is giving power to OK Google. OK Google in turn organizes all his demands. It gives him remindings. It gives him what sort of inputs he needs when we go to an office, when he is at home, what is to be done. Everything is automatically given by OK Google. So such a nice thing. It is something to our OK Google is a virtual assistant, virtual PA, even more powerful than our actual or our human PA. Okay, and moreover, this human, as you know, as we are getting older and older, our memory power comes down, our inclination will come down. Whereas if you take this 180-degree out of phases, also higher in cost today. This chips and I would say a small memory card. So if you want to go for service station, just take this chip or this memory card and give it to the service people. They give it, and they will find out what are the errors or what are the shortcomings in car performance, and they will suggest and do their work. Okay, so there is a physical card which is to be inserted in the car and to be removed and handed over to service personnel. But if you think of this is done automatically. Whenever there is a problem, the car is made so intelligent that it informs the problem to the service station on its own. We need not identify what is the error, because we humans can identify the error only when it explodes. Right? When the problem triggers, we may not be able to identify it. Only when the problem explodes, we come to know of that problem, and we take our automobile to the nearest service station for rectifying it. But if the car is made intelligent to identify or to maintain itself, it is really a wonderful thing. And IoT is one such move towards making our car intelligent, or our car is a machine learning thing because it learns. Okay, and again over a period of time, based on your style of driving, the way the path that you travel regularly, and the number of persons traveling in a car, your car enriching its intelligence, knowledge, to tune its operations to best suit our needs. Okay, so this is really wonderful. IoT is moving towards it. Okay, and not only that, if you take your household appliances or names it, whatever it may be. Okay, if they are equipped with IoT, our inferences, our interference, I can say our inferences and interferences are not that much required. The machine itself will take care of its health and its performance. Okay, so I'm sure in that aspect, this FDP, IoT and machine learning will enrich our students, enrich our participants who are teachers from all over the world. I'm really happy to see participants are from Finland, South Africa, and Saudi Arabia, and several other countries. It is the very first time I'm seeing such a international participation in an FDP, to the best of my knowledge. Okay? So I'm sure that this FDP will enrich our teachers to enhance their knowledge, to get new exposure in the area of IoT, and to make themselves, what I can say, learn new things, tune for new demands, tune for new requirements, and to have a wonderful and successful career, and also their smooth life. I am sure that all the participants at the end of this one-week program will take back the ever cherishable technical content to their hometown. Okay? And with these few words, I congratulate the organizers for their efforts in organizing this event. Three phases. So first two phases are already over. third phase which has just started, and I wholeheartedly appreciate the efforts of the team led by Dr. Jagannathan in organizing this wonderful event. And I take this opportunity on behalf of all of you to welcome a warm and great welcome to our chief guest, Dr. Moorthi, who is going to give his guest lecture shortly. And once again, I thank you all for this wonderful opportunity and sign off. God bless you and thank you.
Thank you, sir. Rahul, sir.
Thank you, sir. Thank you for your words, sir. Then I call upon our head of the department, Dr. S. Jagannathan, sir, for
Rahul, sir, we can proceed, sir. Chief guest introduction. You can proceed, sir. Rahul, sir.
Okay, sir. Once again, good morning all. It's time to start our session of STTP Phase 3 in the topic Influence of Embedded Systems for Industrial Applications by our eminent speaker, Dr. S. Moorthi, sir, Associate Professor, Department of Electrical and Electronics Engineering, National Institute of Technology, Tiruchirappalli. And some words about him. Sir completed his postdoctoral fellow at KTH Royal Institute of Technology, Sweden at the year 2010-2011 the topic Reconfigurable Architectures. Completed his doctoral research in Anna University, Chennai 2008 in the topic VLSI Design, and completed his Master in Engineering in PSG College of Technology, Coimbatore in the year 2003 in the topic Applied Electronics. Sir completed his undergraduate in Department of Electrical and Electronics, University of Madras in the year 2001. Sir has teaching experience in various reputed institutions like BIT, MIT, NIT. Sir holds fellowship awards like a postdoctoral fellowship in the year 2010 to 2011 and Wing Faculty Research Fellowship in the year Jan 2018. Sir filed 5 patents, published many research papers and research projects for agencies and consultancy projects. Sir organized many workshops. His area of interest is VLSI, digital signal processing, embedded systems, digital controllers for power applications. Sir holds professional memberships like senior member in IEEE, IAC, SIT, and life member in ISTE, IETE, MIE. Sir, I welcome you, sir. Welcome you for this session, sir. The session is yours. Please take over the session, sir.
Thank you, Mr. Rahul. Good morning, one and all. It's a great pleasure to be part of this workshop and to inaugurate this workshop and give a lecture on influence on embedded systems for industrial applications. I have been associated with this institute for a long time through Professor Jagannathan, HOD Tripoli, and Principal Kumaran sir. I have been working along with them for many different instances. It gives me a great pleasure right now to get associated with this phase 3 of AICT sponsored workshop on machine learning and Internet of Things for industrial applications. So these few words, let me share the PowerPoint presentation to start my lecture. Mr. Rahul, can I present it?
Yes, sir. Yes, sir.
Yes, sir.
I think then you need to stop presenting, I believe.
Yeah, yes, sir. Of course.
Okay. Thank you. So, influence on embedded systems in industrial applications. Stop me wherever you have any doubt. Am I audible clearly? One of you can.
Yes,
Yeah.
sir. Yes, sir.
Yeah. Okay. So when we get into the influence of embedded systems in industrial applications, before going to what is an embedded system, we need to know what are the different industrial revolutions that have happened in the world. So when we go with Industry 1.0, mechanization of it totally involves with the mechanical aspects of industrialization, where steam and water power generation and equipment related with steam and water power has been machinized, and it has been made commercially available. And after that, Industry 2.0 made a mass production, and they concentrated more on electricity power components. And getting into Industry 3.0, they concentrated more on electronics and IT systems with an intention to work on automation. And finally, now Industry 4.0, which involves more on cyber physical systems, where the automated systems, whichever that has been evolved in Industry 3.0, has been used very much practically here in the Industry 4.0. So again, to say a few words on Industry 4.0, it's a fourth industrial revolution, which are not normally classified as an industry. So it concentrates on certain areas like smart cities, and the concept of factories in which machines are augmented with wireless connectivity and sensors and connected to a system that can visualize the entire production line, control, and make decisions. Yeah, so when we get into the Industry 4.0, the trend towards automation and data exchange in manufacturing technologies are mainly concentrated with processes which include cyber physical systems and Internet of Things, then industrial IoT and cloud computing, cognitive computing and artificial intelligence, and smart manufacturing and smart factory. So when we get into Industry 4.0, the challenges and opportunities of various technologies, and you see here, it involves with the mobile devices, cloud computing, then IoT platforms. Then we have to ensure the authentication in fraud detection, then big data analytics and advanced algorithms, and smart sensors, 3D printing, and advanced human-machine interfaces, location detection technologies, etc. Same way, when we get into the Industry 4.0 components, cyber physical systems, Internet of Things, smart factory, and Internet of Services would be forming the main components of Industry 4.0. Getting into cyber physical systems, it is going to involve with three aspects. One is control. So the perfect monitoring and control need to be done. In addition to it, a proper computation for this control and monitoring need to be done. And whatever we have monitored and controlled, if we need to communicate to any distant places, it need to be done with a proper sophisticated communication technology. So these three C's are going to be important aspects of cyber physical systems, wherein computation, control, and communication environment. So it is a system of collaborating computational elements, controlling physical entities, and they are the physical and engineered systems whose operations are monitored, coordinated, controlled, and integrated by a computing and communication core. So when we get into the cyber physical systems, there are different different areas in which the CPS is going to play an important role. For an example, since we are in electrical engineering, we mainly take up the electrical example here. So the smart grid or a self-driving car or a smart manufacturing plant. Okay, these are certain examples for the involvement of cyber physical systems and Internet of Things. So when we see here, cyber physical system comprises interacting digital, analog, physical, and human components engineered for function through integrated physics and logic. So the examples of CPS, when we say CPS, that is cyber physical systems, which need not have IoT at all instances. So there are certain instances where the cyber physical systems exist without the intervention of the IoT. So example for it is a Segway scooter and a smart spoon enabling Parkinson's patient to feed themselves, and autonomous vehicle. I think one of the experts is going to handle autonomous vehicle in your lectures. So autonomous vehicle operating without any wired connections. Um, for example, a Mars rover operating between the messages from Earth towards the unit. Okay, so those are called as a cyber physical systems. Okay, so when we get into this Internet of Things, when we go into Internet of Things, the Internet of Things hold 3 or 4 main parts in it. One is called embedded systems and sensors, actuators, and radio interface. So when we get into these four aspects of Internet of Things, the main or the brain of your Internet of Things is going to be your embedded systems. So the embedded systems is going to fetch the values from the sensors as input to the embedded system, and it will try to compute whatever the values received. With the values received or with the computational elements that are going to be implemented in an embedded system, whatever the computed value we are going to have inside it will try to actuate the further movements. So the actuators are going to play an important role at the output point. And when we want to communicate these processes to a distant location, then we need a radio interface. So the radio interface might be in different forms. It might be a short range or a wide range, or it can be of a local area or a wide area. It depends on the requirement of the user. Okay, so the embedded systems play an important role as a brain here in between the input and the output. Let us see what is an embedded system. So embedded system has its own conventional definition that it is a combination of software and hardware which is meant for a particular application. Okay. So that's the I even stand with the same definition of embedded system, which is a combination of hardware and software which is developed for a specific application. It's a so when we get into the characteristics of the embedded systems, the characteristics of the embedded systems include it is a single function. The name single function makes names that say it can execute a single program repeatedly, or on the other way, if you want me to say, it can hold many number of programs, but only one program will be executed at a particular point of time. Just hold for a 1 second. I'll just come back. One second. Just be online. I hope it is visible now, right?
Yes, sir.
Yeah. So it is a single function unit which can be told as it holds more number of programs, but only one program will be executed at a particular point of time. And obviously it is tightly constrained because whenever we go for buying any cell phone or any kind of electronic gadgets, we will be looking for a very sleek and compatible uh, gadget which holds a less amount of area. So technically speaking, it is the requirement of any user that the gadget should occupy less area and it should withstand for a long period of time between subsequent charging. So the low power concept comes there, and it has to perform with more number of applications. That would be the expectation of any of the user. So it is tightly constrained. So the manufacturer or the the engineer, designer has a high responsibility to look for a low area, low power, and low cost devices to be designed and produced. So apart from this, more number of more number of applications also need to be added to it. So that's the main constraint that are faced by any of the embedded system designer. And coming to the third point, that is reactive and real time, it should continuously react to the changes in the system's environment. Um, Without any delay. So there should not be any delay in the computation. There should not be any delay in the response to the inputs that are fed to it at any point of time. So that's the third point. When we get into the example for any embedded system, say for example, a digital camera IC, if I happen to take this, you can see here, um, you can see here that say so many number of pre-processors, co-processors, um, and interface controllers are available. Apart from that, we also have a dedicated microcontroller available as a center part of it. So when we altogether take it and analyze this digital camera IC for any embedded system, it is a single function because it can work only as a digital camera, and we obviously require this to consume less amount of power and high performance than low cost. So it is tightly constrained. Then reactive and real time these days it is to a higher extent because this I have mentioned long back, so only to a small extent. But these days we take the pictures even in a very fast moving environment. We could take a picture without any blur. So the system has become a good reactive and real-time system. And what is a real-time system? When we get into the real-time systems, it processes events. Again, here the external inputs cause the events, and those events will have a primary objective of minimal response time. So the events should consume very less amount of response time. Thereby, the system will respond very fast without any failure. So when we get into the types of real-time systems, we have hard and soft real-time systems. Just you can go through the definition for soft and hard real-time systems. Thereby, I would like any one of you to give an example for a soft real-time system and hard real-time system. So soft real-time system is a system which computes output response as fast as possible, but no specific deadlines that must be met. When we go into hard real-time systems, the hard real-time systems will compute output response with a intention of a specified deadline, or if it is not going to meet that deadline, then the system will fail. So ATM machine for which hard real-time systems. Okay.
Odd real-time.
Yeah, that's a good example. If it is not going to meet out the deadline, say suppose um, the response time is going to be high, then it will become a problem. Sure. Okay, so usually what example I used to give is two extreme examples I used to give it here. One is for soft real-time systems, the toys which uses embedded system, say a toy which claps and walks. Okay, if it is not going to meet out the deadline, it is not going to have any huge impact. So that can be taken as a soft real-time system. Similarly, a washing machine, if it is going to take a long time to wash, okay, say instead of 1 hour, if it is going to take say 1.5 hours or even more than that, that may not have much impact. So I take that also as a soft real-time system that is not meeting out the deadline. And for hard real-time systems, again, I take a very extreme example that a controller used to control the fission process in nuclear power station. If the controller is going to fail in meeting out its deadline or response time, then a huge impact will be there on the environment. And when the system fails, the impact will be more on the environment. So that is called as a hard real-time system, where sometimes where you might need a redundant system there to uh, to work or to ensure the proper functioning of that particular controller. So there are three key embedded technologies available. I mean, three key technologies which are going to control your embedded systems are available, where it goes like, say, processor technology, IC technology, and design technology. And coming to each technology, we'll try to see what are those technologies. And when we come to design technology, we have two sets of designs here. So one side we have a microprocessor as the target device hardware. So to operate this microprocessor or a microcontroller, we need a programming language. So the programming language might be the programming language which you can take up here as a C or C++ or Java or even Python. You can go ahead, but those programming languages will be converted into machine level instructions and will be operating the microprocessor or a microcontroller. And when we come to the other side of the design ladder, we could see that the target devices are say field programmable gate arrays, which is in short called FPGAs, then programmable logic devices, which is in short called PLDs, and application specific integrated circuits, in short ASIC, will be there as a target hardware. So here in ASICs, probably you might be fabricating that as an IC. So other two are readily available. FPGA and PLDs are readily available here. So you can take the field programmable gate arrays or PLDs as the target device here, and the programs will be written with the help of the hardware description language. And these hardware description languages will be converted into a synthesizable hardware with the help of logical synthesis step. And after that, it will be implemented inside the FPGA or PLDs. So you can now differentiate the two designs. One is only with the programs, and the available hardware will work on it. And here the programs will be converted into a hardware, and it will be deployed as a system inside the FPGA or PLDs. So the difference between the say the programming language and the hardware description language, there is a difference between programming language and hardware description language itself is available to say the difference between the PLD FPGAs and microprocessor and a microcontroller. That is, the programming languages will execute the programs sequentially. So any programming language will try to execute the programs sequentially, but your hardware description languages will execute the programs both sequentially and concurrently. So here you can easily understand that the target hardware also going to work in the same way. So the target hardware of, say, microprocessor or a microcontroller will have a sequential execution of programs and sequential execution of any of the particular work. But when we get into the hardware description languages, it is going to execute the programs in concurrent and sequential manner. So the same way the FPGAs and PLDs are going to work. Okay, so both concurrent execution of any system and sequential execution of the systems can be implemented. Coming to the processor technology, we have three types of processors available. One is called general purpose processor and application specific processor, and the last one is a single purpose processor. You can see here the general purpose processor holds two sets of memory units. One is called program memory and data memory, and both these memory units will be accessed by the in addition to this particular memory unit, the access of any of the programs in the program memory, which is stored in the program memory, can be done by the user. And when we go into application specific processors, we have the program memory and data memory, but the programs which are stored in the program memory will be only read by the user, but he or she cannot modify the programs which are available in the program memory. And apart from this set of programs which are stored in the program memory, some small programs which will be stored in the data memory along with the data can be accessed by the user, and they can modify and even edit the programs which are stored in the data memory. And the name itself says that it's an application specific processor, where it means that it is designed for a particular application. So whatever the programs that are related to that application will be stored in this program memory. And when you want to change the application, then the entire concept of that programs need to be changed, and we are supposed to change the program memory and data memory together. In addition to that, based on the required application, the controller and data path unit also will be having a change. Coming to the single purpose processor, again the name says that it is meant for a single purpose. So the program whichever has to be executed will be stored in the data memory itself, and it will execute only one program at any point of time, and the same program can be repeatedly executed at any number of times. So coming to the say the examples for it is a conventional microprocessor or a microcontroller unit will be your general purpose processor, and a coprocessor or an accelerator or a peripheral controller unit can be an example for single purpose processor. And for application specific processor, it's a compromise between the general purpose and single purpose processors. So it will have a good flexibility and good performance, and the size and the power of the processor also will be taken much care. So going back to the digital camera IC, we have a microcontroller unit and a DMA controller unit. The DMA means that direct memory access. Hope all of you might be knowing what is direct memory access. Direct memory access is accessing the memory which is attached to the microprocessor by the I/O devices without the intervention of the microprocessor. So when a controller wants to enable this access of memory which is attached with the microprocessor by your I/O devices, it will be enabled with the help of a single program execution in this DMA controller. So this DMA controller is going to execute only one program for a particular application. So it is called as a single purpose processor. And microcontroller, which is mentioned here, can be used. If I take out this microcontroller, if I take out this microcontroller and place it somewhere else, this microcontroller can be used for some other applications also. That's why it has been categorized as a general purpose processor. So coming to the last technology, that is IC technology. You could see here a particular IC is placed over a fingertip, which occupies a zero PCB space, which is a microcontroller unit. A complete microcontroller unit can be made with a very, very simple and small size. So that is again based on the mass technologies. The recent mass technologies have got improved a lot for the digital systems, especially for the digital systems. So when we see the chart here, in 1980s, it started with a 2 micron technology. And after that, it went down and down to a level of 32 nanometer. And these days, for digital, that is discrete ICs, for discrete ICs, it has gone to a level of 10 nanometer or even 7 nanometer technology, where it works only for the MOSFET as a switch. So to a level of 10 or 7 nanometer technology, you can presume the what would be the power that is consumed. Say even for a 2 micron technology or 1.2 micron technology, the operating voltage might be of around 12 volts. When we get into 0.5 micron, it has reduced to 5 volt. And when we get into 0.35 micron technology, the operating voltage of the circuit has got down to 3.3 volts. And 0.18 micron technology with a 1.8 volt as its supply voltage. And just consider that when it goes to a level of 10 nanometer or a 7 nanometer technology, the power consumption has gone down to a very, very low level compared to the conventional one these days. But this also limited to the discrete ICs, because when you go with analog ICs, the technology has not gone to a level of 10 nanometer or 7 nanometer. It is very much limited to 90 or 65 nanometer technology, because analog ICs have to work in the linear region also. So in the linear region, when you want to operate any MOSFET in the linear region, it might require a proper reduction in its size. The reduction in the size cannot be done all of a sudden to a level of 10 nanometer or 7 nanometer technology. So this is the limitation of analog ICs. But however, the discrete ICs can go to any level of 10 nanometer or a 7 nanometer technology. So the embedded systems enabled applications, you can see here, so many number of applications are made in different areas, like say utility metering. We have electricity meters, gas meters, flow meters, and smart meters. And going okay. So it goes like for other consumer electronics and portable medical devices. Hello?
Yes, sir.
Hello?
Please continue, sir.
I, yeah. I heard a noise, so I thought some problem. Okay. Portable medical units are also available, like blood glucose meters, thermometers, heart rate monitors, etc. And coming to the power applications, you could see that a robust power system is available on one side, and we have the sophisticated communication technology on the other side. So to interface these two systems, we need a proper electronic interface which can be done with the help of the embedded systems. So the embedded controllers will play an important role in between the robust power systems and sophisticated communication technology. When we get into this, you can see here the phasor measurement units. The phasor measurement units require a GPS receiving unit to have a time stamping. So the time stamping will be done with the help of the GPS clock. So the GPS receiver will be placed inside this PMU, and they'll take the time stamping from the GPS clock. Suppose if two if two PMUs are placed on apart in two different places, then if a circuit breaker is going to say operate due to a particular fault, if you want to identify which circuit breaker has operated at a particular point of time, then we need the common clock. So the common clock between PMUs, PMU1 and PMU2 should be made. So to make a common clock, they take GPS clock and they'll try to work along with the GPS clock on both the PMUs, so that both the PMUs will be working with the same time instances. So there won't be any change in the value of timing in PMU1 and PMU2. So whenever there is an operation involved in a particular circuit breaker, with the time stamping, you can mention that this is the time at which the circuit breaker has operated. So you can identify which circuit breaker has operated first, and where is the fault, the nearby fault can be identified accordingly. And coming to the community-based microgrids, so we need a perfect digital controller for each and every, microgrid operation, where either to monitor or to control, we might need a proper embedded system. So coming to a sensor node, a proper microcontroller or a microprocessing unit is required along with the sensors, and a proper communication module is also required, and a proper battery backup is required to feed all these sensors, microprocessors, and communication module. And this is one example, that is energy harvesting from the power line, and the stray magnetic energy harvesting via inductive coupling is done, and with the help of it, the wireless RF sensor node is powered with a proper power management system. So the power management unit will work effectively to convert the stray magnetic energy into a proper power to feed it to the wireless RF sensor. And coming to the smart grid applications, we have four areas in which the smart grid is involved. That is the electrical infrastructure, then communication infrastructure, computing functionality, then smart grid applications, going with appliance coordination or remote metering or PHEV charge coordination, etc. All these four areas need a proper security at any point of time. So to provide a proper monitoring, control, and security, we might require the use of embedded system at every point of this area. Say when we take computational functionality, the data collection and storage needs a proper embedded unit. And for decision making, we need a proper algorithm which will be implemented using an embedded system. And for communication, again, either as I mentioned before, it is again based on the amount of area which we are going to cover up. So if it is going to be less, then we can go with a proper type of ZigBee or WiMAX or any short range communication. If I want to go with a wide range of communication, then we need to go with a Wi-Fi or LAN or a WAN type of arrangement, where we can cover the a particular locality altogether. And coming to the electrical infrastructure control, again here also we need certain digital controllers to make it operate properly. You might have heard of numerical relays, etc., where the involvement of the digital systems is very, very critical. And coming to the hybrid power systems, here we have for the regulation and conversion, we might require the proper controller to feed a perfect set of values to the load. So when you want to feed a proper power to the load with the different renewable energies that are interconnected here, we might ensure that the power is available from any of the sources apart from the conventional generator. So we need to ensure that the battery banks are charged properly and the load is served in a proper way. So without any interruption. So if the load is going to be a critical load, then we are supposed to ensure that it has to be powered at all times without any interruption. And coming to the smart meters, these days people talk more about smart meters where the current sensing and voltage sensing will be done and it will be fed to the processor, and thereby the power and the energy will be calculated, and with a proper digital isolation it will be communicated to the other side based on the range of communication. This is a practically deployed smart meter. When we get into today's electrical power systems, we need a proper energy storage, then a proper distribution substation, a control center, and a proper charging station for any EV systems. So this can be done with the help of properly fetching the values from the fetching the power or getting the power from the bulk power generation units and distribute it accordingly. So the information flow is also important compared to the power flow here. So the information flow will be totally taken care with the help of your embedded systems. Coming to the transformation in power systems, you can see the traditional power. It's a one way of flow of electricity, but here we have in the present day smart grid, we have the two-way flow of electricity and the information. The information is also required from the consumer towards the producers, and the information also need to be sent from the producers towards the consumers. At all times it is being sent, but here we need the other way of working also. So to make any grid to be smart grid, then the two-way communication is very much important. Thereby the units are being operated. Say units can be operated at a particular point of time without any interruption. And coming to the hybrid electric vehicles or EV systems, you can see here a power control unit and a charging unit is required. And you can see here each and every portion of your HEV or EV system requires a proper control unit or a management unit, which will be deployed and which will be implemented with the help of a digital controller. So here I have mentioned it as an FPGA application. So when you see the controllers which are deployed here with an FPGA, say it can be used for co-processing, that is noise filtering, or for hardware acceleration, or for motor control, or DC-DC converter control, or AC to DC converter control, or for PWM generation, or format conversion, etc. For many applications, we can deploy these digital controllers, which can be made of microcontroller unit or an FPGA unit. So when we get into the standard hybrid EV power and controller architectures, you can see here from a particular say generation unit, you can when you want to even take it to a battery, we need a proper inverter and converter units where each and every portion of it will be controlled with the help of a particular microcontroller unit here. You can see that there is a requirement of individual controllers available here. Microcontroller units are required for DC-DC control, motor control, and generator control separately. But when you get into the simplified hybrid EV power control architecture using single FPGA, where the single FPGA will try to produce the PWM pulses and control all the three units with the help of a single controller unit. So this is the speciality of any of the controllers. In the early days, they used three microcontroller units, and a simplified architecture can be made with the help of an FPGA, where all the three units are also controlled by a single embedded control unit. So this is always possible. Like this, we can make many optimized digital controller units with the help of the sophisticated embedded systems which are available right now. Okay, so I think we are to the time, I believe. Sir, is that time or?
Sir, you please continue, sir.
Okay. So when we get into the same slide of Internet of Things, we could see here the embedded systems play an important role in developing the Internet of Things. So it connects everything like a physical object, persons, living organisms, concepts, resources, services, etc. together, and anything that is interesting from the perspective of an application will be interconnected. So with the help of the smart objects and devices, you can interconnect the things. So we'll be using a sophisticated sensors like say for environmental analysis, and we need a temperature sensor, CO2 pressure, and ambient light sensors. Then when we want to have a proper detection units like presence detectors with the help of PIR sensors, that is pyroelectric infrared sensors, or a gas detectors or IP video cameras, etc. that can be used. And for communication, we can go with a Zigbee or 3G or Wi-Fi or Ethernet gateways can be used. And several sensors and actuators are available, which are very much compatible with the digital controllers. So you can see here that they are going to play an important role in the automation. So the motion, velocity or displacement, humidity, and gas sensors, then torque sensors. And when we go with the acceleration or tilt sensors are available, and for to know the presence and position and proximity, the proximity sensors, then
Sir?
yeah. I got a problem with the transition of the slide. Okay, so the connections, we have different types of network connections, like say wide area network, metropolitan area network, local area network, and personal area network. So based on the requirement, you can choose any of these networks and you can deploy it and you can interconnect the embedded systems. Coming to the IoT in smart cities, you can see here so many number of applications are available in a smart city concept, where we have a smart mobility, smart parking, smart wearables, then car to car, that is vehicle to vehicle communication, then supplying the water quality can be checked, and the traffic priority, then going with smart grids, security and surveillances with a smart communication unit. And similarly, utility management, etc., can be made with the help of the IoT concepts. And coming to the smart building, as you know that each and every portion of your home can be automized and made smart. So if you want to identify whether the person who has come and waiting in your doorstep as a known person or a not, then you can easily identify by a proper authentication. Similarly, living room automation, bedroom and rooftop power, you can, with the help of rooftop, you can generate power, collect the power and use it for your applications. Then different portions, each and every portions of your home can be automized. And autonomous cars, which the other expert will be dealing, will have a good communication between the cars so that we can avoid the accidents. Then drones, use of unmanned aerial vehicles for different applications. Then coming to the smart grid, as mentioned before, a proper communication between the consumer and the producer can be made. The environmental monitoring is very much required. Thereby, you can control the pollution. So CO2 sensors, then pressure sensors, temperature sensors, then say any kind of say sensing unit which are relevant to the environmental monitoring can be deployed, and you can identify how much pollution the environment is experiencing, and based on that you can reduce the pollution. So digital monitoring of water supply. So the pipelines will be sensed with the help of different sensor nodes, and it will be monitored, and it will be see, after monitoring the pipelines, the information will be sent to the control center. And parking, many times we will be suffering due to the non-availability of space for parking, or we may not be knowing there is a space that will be available very much nearby, but we may not be knowing whether the space is available or not. So the smart parking says that where the exact parking place is available for us to park the vehicle. And smart bins. So if the bin is filled, at times we could see that the bins are filled and no one is there to clear it out. But here these smart bins will try to inform the say clearing or scavenging units that how much it has been filled and whether it is reaching the particular point for which it has to be cleaned. So here you can see that it is around 60 percentage, and when it reaches around 80 or 90 percentage, it will give the information to the nearby scavenging station so that they will clear it immediately. So to that level, the applications are made with the help of the embedded controllers. You can see here the diversified applications of embedded systems in different applications like home, transport, health, building, and cities. And to say a few, when we get into homes, we have a good energy monitoring required and irrigation controller. Even a water level control is required for say for us to control the flow of water into the tank, water tank, so that it will not have any overflow at any point of time. And coming to the transport, we might need a proper say packaging, monitoring, and smart parking is required. And coming to healthcare, we need a proper remote diagnostics are required. And coming to the building infrastructure, we may require each and every point need to be automated. And coming to the cities, we need a proper emergency services and waste management, and surveillances are very much required. So the need for basic research for IoT is depending on the machine learning and networks and systems and control. we should start from systems and control, because whatever the application which we are going to work on might need a monitoring and control. So monitoring and control will start with the systems and control, and with the help of a proper machine learning, that is, with the help of a proper algorithm which works with the previous data, you can analyze it and you can take decisions, and the decisions taken can be transferred to a proper controller with the help of the networks. So a proper network is required for communicating it to the controllers. So we need three areas which come into effect with my IoT. One is systems and control, machine learning, and networks. Okay, so these are the three areas which need to be concentrated more for the development of Internet of Things. So I've come to the end of my lecture. This might be the last but one slide which I used to show it during my lectures. The only true teacher is he who can really come down to the level of student and transfer his soul to the student's soul and see through and understand through his mind. Such a teacher can teach really. He can teach none else. I was told by Swami Vivekananda on India and Her Problems book. Any queries, you can raise it now.
Sir, there are
Sir,
some questions in chat box. Rahul sir will answer. So we'll ask one by one.
Yeah, please.
okay, sir. One by one we start reading, sir. I will start reading, sir. First question, sir.
Yeah.
Sir, can you give the name of the microcontroller used for the phase measurement unit?
Can you come again?
Can you give the name of the microcontroller used for phase measurement unit? Phase or measurement
No,
unit?
it depends on it. See, it depends on your requirement. See, phasor measurement unit is there. Okay. If you want to use any of the microcontrollers, let's say, for example, if you want to use MSP 430 or Arduino, that is Atmega 8, or Raspberry Pi, or leaving out all these microcontrollers, and if you want to go for FPGAs, you can go ahead with the development of FPGA controllers for your phasor measurement units. This is the actual work which we are doing it right now. Use of FPGA controllers for phasor measurement units is the work which we are taking up now and working on. So you can go ahead with any of your controllers. That is not, see, it is not restricted to any particular controller that need to be used. See, only thing which you need to see in any of the controllers is its versatility to communicate or get the inputs from the external world. So if it is going to have a proper analog to digital conversion unit attached to it in just before the input of any of the microcontroller, then you can go ahead with any of the controllers which I have listed right now.
Okay, sir. I think it's clear. We move to next question, sir. Can we use WSN in communication infrastructure of smart grid?
Yeah, you mean wireless sensor networks? Wireless sensor networks, you can use it. See, wireless sensor networks, deploying wireless sensor networks in your smart grid makes it more versatile.
Okay, sir. Next question, sir. Are there any challenges in the use of embedded system in industry devices?
In industry?
Devices.
Devices, no. See, challenges in the sense, that's what I mentioned here right now. See, for a smart grid application, the controller might say, if I'm going to use only one controller or two controllers in the smart grid applications, see, one on source side and the other on the load side, then those controllers should have a capability of getting all the or sensing all the inputs. Say, for example, a controller, an FPGA controller which is placed towards the source side, need to take so many number of values into it, and it has to process and it has to give the results based on it. Say it has to, say if it is connected with a source side which has PV and which has a wind energy conversion system, which has a battery unit, and which has also the diesel generation, conventional diesel generation unit, then the voltage and current values of all these units need to be taken, and it has to be processed, and it should say that what is the level of power that is produced from PV, what is the level of the power that is produced from wind energy conversion system, and what is the state of charge of your battery, what is the level of power that is produced from the diesel generation unit. All these need to be computed, sensed and computed. So when you want to sense all these values and compute, we might require around 18 to 19 level of channels that are required for an analog to digital conversion. So if any controller is going to have this ADC channels are of around 18 to 20 which are attached to it, then you can go ahead. I would see that the versatile, the computational capability of any of the microcontroller or any of the digital controller would be very good. But only problem is its communication with the external world is being limited. So if you make the communication of your microcontroller to the external world, that is to handle the inputs, as many number of inputs as it could do it, then there won't be any challenge at all. So if you sort out this challenge, then any of the controllers can be used in any of the industries.
Excellent explanation, sir. Thank you, sir. Sir, then we move to next question, sir. It depends upon previous question, sir. Can WSN be used in all domains of smart grid?
Yeah, you can use it.
Okay.
See,
sir.
here in wireless sensor networks, again, the same aspect of, say you need to sense all the values, and you need to run the algorithm based on the sensed values, and the control aspect, whatever the control actions which you want to do it, you can communicate through wireless communication, and you can make it effective with the help of wireless sensor networks.
Okay, sir. So we move to next question, sir. Can you suggest few low-cost sensor nodes for agriculture applications?
Agricultural applications, you can make the sensors, sensor nodes with the help of Raspberry Pi or Arduino. You can make in an effective way by interfacing any of the sensors, any of, say, like moisture sensor, or say if you want to measure the pH level, okay, a moisture sensor can be attached with it, and you can program, you can sense the values of this pH sensor, and based on it you can suggest what type of crop that can be grown in a particular place. Okay, so even that is possible. Say if you make a gadget, you can make a gadget and you can say that based on the pH value, based on the moisture level that is available in the particular area, you can suggest what type of crop that can be grown. Even that can be done with the help of the gadget whichever you are preparing. So those gadgets can be prepared with the help of the I think low-cost controllers are available. One such as your Arduino or Raspberry Pi can be used. Okay. Right.
Okay, sir. Next question, sir. Can the embedded system influence the productivity when automated in what level?
Okay. So right. See, when you want to change the aspect of production, okay. So when you want to change the production chain, Okay, production chain from, say, instead of 1 2 3 4, if you want to change as 1 3 2 5 4. Okay, so if you want to change it, if you want to change this set of production chain, then it is very easy with respect to the digital system compared to the conventional analog systems. When you go with conventional analog systems, the by easily changing the programs, you can do it in digital, but you need to change the entire system itself, entire circuit itself in analog circuits. That's the main advantage of any digital system. One more thing is the digital. When I start using the digital ICs or digital controllers, it is immune to noise. So the noise that is produced from any of the industries also will not affect my digital controllers.
Next question, sir. What are the microcontrollers that are easy for IoT applications?
I think many of us, or many of the people who work in digital controllers uses Arduino, that is Atmega 8 controller, very extensively, and apart from that Raspberry Pi they use. Then one specific controller which you want me to point out is CC3200 is there. CC3200 is from Texas Instruments. That Texas Instruments IC is, say, it holds both the controller and also the communication module. So if you want to have a proper controller, that is MSP430 will be as an embedded one inside your CC3200. In addition to MSP430, we also have the communication module available. So whatever you are computing, if you want to communicate to the distance, then you can make it with the help of the same IC, that is CC3200, which was produced by Texas Instruments. I'm giving one example. I'm not the brand ambassador of TI, so don't take it like that. Just one example I'm giving it.
Okay, sir. Thank you, sir. All your answers are very excellent explanations, sir. Thank you, sir. Your session is more informative, sir. A very good
Thank
session.
you. If you have any queries, you can send the mail to my ID. And thank you. I thank the management of
Thank you so
Dr.
much, sir.
NGP Institute of Technology, and the administration and the HOD and the coordinators for this workshop, having given me this opportunity to present it. Thank you.
Thank you so much, sir. You received wonderful feedback from chat box. Thank you for a wonderful session, even though you are busy with some other campus activity. So you are joined us. Thank you so much for joining us, sir. Thank you, sir.
Thank you, sir. Thank you. Thank you.
Thank you, sir. Your visual presentations are more informative, sir. When excellent examples. Thank you, sir, for your valuable time with us. Thanks for caring by sharing the knowledge. A huge content during a presentation. All your points are in practical. We enjoyed a lot virtually, sir. Thank you once again, sir. Thank you for sharing your time during this pandemic situation, sir.
Thank you. I think I can leave now, right? Thank you.
Yes, sir.
Yes, sir.
Thank you. Thank you.
Dear participants, your feedback form for this session is shared in the chat box. But feedback form is for the session, but it is not considered for attendance. Attendance is recorded automatically separately. Please stay tuned in the session, throughout the session. All your timing, everything is recorded automatically by using Google attendance recorder. And we know the condition of AACT sponsored STTP, that we have to have 80% of attendance for all the sessions. Then we should have to complete one assessment at the final day of our STTP. Kindly do these things and get eligibility for getting the certificates. Any questions or any issues, you can ask us in the chat box. And thanks for your registration, and we are happy to have you all in this session.
Thank you so much for all the participants joining us with us for upcoming 5 days also. So we are encouraged we are by ACT to conduct this type of program, to organize this type of program for faculty community and research community. So for thanking ACT officials and ACT STTP program director Venkat sir for hosting or permitting us to organize these type of programs. Hope all the participants will receive better knowledge or a lot of take-home message for the entire 5 days. So I wish all you will stay safe, stay home, and with this you can connect with us for new learning about machine learning and IoT for industrial applications. So today afternoon by 2 p.m. we'll join sharply. So because without any delay, so we'll go for, because you are having n number of online classes and you are committed with regular academic works. Even then you are joining us. But if you are joining by sharp 2 p.m., so we'll wind up 3:30 or 3:45. So we'll go for other works and all. So any doubts or any clarification regarding what joining and attendance monitoring and any other things, you can we'll ready to answer this session. Any clarifications required from the participants? So dear participants, your time is valuable because you are busy with a lot of works. I know this difficulty. So any works, so any what thing is clarification is required for meeting? Yes, please, you can chat or you can unmute yourself, you can ask directly.
Dear participants, if you don't have participants ID in the PDF, kindly give me your full name, institution, and mail ID to my mail ID rahulkumar@drngpit.ac.in, and I will add it to the confirmation mail ID. Then I will generate participants ID to your mail IDs. So if you don't have participants ID right now, please use the code ABCD, then submit the feedback form.
So we are trying to connect all those things because we need to submit all the documents with participant ID. So that is why we are requested. So no other hidden agenda for this.
Sir, this is Gajendra. Jaigandan, sir.
Yes.
Thanks for the,
Sir Gajendra, good morning.
the second.
Good morning.
Sir. Hello.
Yes, sir.
Hello, Jaigandan, sir.
Yes, sir. Tell me, sir. Tell me, sir. I'm here only.
Sir, congratulate you for the second ACD FDP, sir. So it's also a nice session, sir.
Thank you.
Attended. And thank you to Rahul also.
Thank you, sir.
Okay, sir. Thank you, sir. Thank you, sir.
Dear participants, our afternoon session will start at 2 p.m. Kindly join before 10 minutes, then it will be helpful for everyone. Also, please kindly mute your audio and video during the sessions. It will create a lot of disturbance for the participants. It will be helpful if you are muting the audio and video. Kindly make session as healthy as possible. It will be more interactive.
So
Sir,
if
I
there is
have a
no
question.
clarification, if you are submitted,
Yes, ma'am.
yeah. Tell
Sir,
me.
it is like you have told that there will be evaluation at the end of the session. It's something like we should have minimal score or something like that.
Yes, ma'am. Evaluation.
Yes, ma'am. Yeah, ma'am. We'll inform, ma'am. We will inform. So
Okay,
no
okay,
problem
sir.
at all. Don't worry about, ma'am. This will be objective only, ma'am.
Okay, okay, sir. Thank you.
Thank you. So once you have submitted, there is no clarification at all, you can leave from meeting. So we'll join by 2 p.m. sharply. And PPT and related materials will send through recorded material through YouTube link. So yes, the slides made available to our mails. Yes, of course, we'll send YouTube link as a recorded video.
Admins will be totally sent to your mail after all the 10 sessions. And the PPT, instead of PPT, the recorded session will be uploaded in the YouTube. Then the YouTube link will be shared in the WhatsApp and also in the mail. If you don't have participants ID right now, please use the code ABCD. Kindly send me your name, your institution, and mail ID to my mail ID rahulkumar@drngpit.ac.in. I will generate the participants ID and send back you the participants ID. Once again, I am repeating that our session will start by 2 p.m. afternoon. Kindly join the session.
Atul Kumar sir asked one question about attendance. Yes, sir, we are based on attendance monitoring. So,
We
no
will
issue at all,
consolidate,
sir. Please.
we will
Yes, sir.
consolidate all the 10 session attendance. Then I will send to your mail, sir, at the end of our STTP with examination result.
Sir, Atul sir, you don't worry about this. We'll follow up, sir. So, we requested today's guest to finish by 11:30 itself because any clarification required. So that only we are requested to finish 11:30 itself. So, if there is any clarifications, will be there, or otherwise you can leave from meeting. Thank you so much, all the professors, for joining us.
Once you completed feedback, you can leave the session. You can rejoin by 2 p.m. Thank you all.
Rahul sir. Rahul sir. Salvika,
Yes, sir.
Brian.
Yes, sir.
No other questions mean we can what?
No, sir. No question, sir.
Yes, sir. So no need to wait. I think all will be.
Okay, sir. I will remove.
We'll close the. Yeah. You can ask once again. If it is there, then.
Sir, okay, sir. We close the session, sir.
Okay, sir.